Hello and welcome to this video on adding or subtracting complex numbers. Now if you recall from previous videos, every number is a complex number, right? Any number that can be written as a real number plus a pure imaginary number, right? The form a plus bi, where a and b are real, is a complex number. So everything we see is pretty much a complex number. And what we're doing in this video is looking at how to add and subtract these numbers, just as though you were adding and subtracting polynomials, right? You'll see that it's very similar to adding and subtracting polynomials. All right, so let's get into the rules here. All right, so on my first page, let's just talk about adding and subtracting complex numbers. So I'll start with adding. All right, now remember, a complex number looks like the following. You have a plus bi, right, where a and b are real. So here's a complex number. And then suppose I add to that another complex number. So instead of a plus bi, how about c plus di, right? Again, another real number plus a pure imaginary. And when you're adding or subtracting, what you're going to see is that we're going to treat I, remember that square root of -1, that I, we're going to treat I like a variable, right, in a polynomial. So when you're adding, you can only combine like terms, so terms that don't have I attached, so the a plus the c will go together. And then the terms that do have I attached, the bi plus the di, I'll also be able to combine those. So the final result, the sum of two complex numbers, is simply, for the new real part, you add the real parts of the addends. The real part of this number is a, plus the real number of that number is c. The real part, so a plus c is going to be the real part of the sum, then plus, and then the imaginary part of the sum, you add the imaginary parts of the addends. So what's bi plus di? That would be the quantity b plus d times I, right? It's like factoring I out of the bi and di, leaving me with b plus d, or just combining the coefficients. Right, it's just like taking 3x plus 4x would be, 3 plus 4, or 7x. All right, so there's addition, and the subtraction is really no different, right? Remember, because subtraction is just addition of the opposite. All right, so when I subtract, I called that adding. How about this subtracting? And when you take two complex numbers, right? Here's one, again, this a plus bi, where a and b are real. And then suppose I then subtract from that, the other complex number here is c plus di. All right, now in this case, you are doing subtraction. So if we'd like, I could rewrite this. So we have, the first number, a plus bi. Wonderful. And remember, subtracting a number is just adding the opposite, or if you want to think about this, this c plus di has multiple terms. Having a minus out in front is really like having a -1. So you can distribute this minus here, distribute -1, and have a plus bi, and then minus c minus di. And then as with polynomials, right, combine like terms, combine the real parts and then the imaginary parts. So the final result, the difference between these two numbers, the real part would be a minus c. Right, I'll put that in parentheses. This is going to be the real part, the real number of the final result of the difference, plus, and then the imaginary part will be bi minus di, or just b minus d times I, right? The quantity b minus d times I. And again, it's just like having 7x minus 4x. You'd have 3x, 7 minus 4x, right? Okay. So yeah, again, very simple. You're going to treat I like a variable, even though it's not, right? I is not a variable. It is a specific number. It is that principal square root of -1. But you're going to treat it like a variable, and then adding and subtracting becomes just like adding and subtracting polynomials. All right, so I have several examples where I'm following these rules. So the first of these is, I have 4 plus 6i, one complex number, right, plus, and then -3 plus 5i. And we're asked to, add these, get their sum. Now really the parentheses aren't necessary, right, because notice there's no negative signs or any numbers in front of these parentheses to distribute, right? Just really like the number 1 is in front of them. So I don't really need the parentheses around these right now, so I can write it without the parentheses, plus -3, and I usually plus a negative, we'll throw parentheses around that to clean that up, and then plus 5i. And again, all we're doing here is combining real numbers with real numbers and imaginaries with imaginaries, right? So the 4 would be combined with the -3. And what's 4 plus -3? That's 4 minus 3, right? 4 plus -3 is 1. So the real part of the final result, the real part of the sum, is the number 1. Okay, then I have, plus, and then the imaginary parts, right? Combine the ones with the double underlines, positive 6i plus positive 5i would make, 6 plus 5i, 11i. Alright, so the real number is 1, and then the pure imaginary number is 11i. The real part is 1, the imaginary part is 11. And that's it. These are not like terms, right? Again, you're treating I like a variable, even though it's not. These do not get combined. You do not add the 1 and the 11. Right, because 11 has I attached to it and 1 does not. So that's as simple as that sum would get. Alright, so the sum of 4 plus 6i and -3 plus 5i is 1 plus 11i. Great. Alright, I'm just going to keep doing this. I got just a couple more examples. It's very simple. I feel if you're familiar with adding and subtracting polynomials. Alright, so here I have a subtraction. I'm finding the difference between these two numbers. We have a complex number 4 minus 2i, then minus another complex number, -2 plus 7i. As I mentioned earlier, when you're subtracting an expression with multiple terms, right, subtracting this number that has multiple parts, this is like having a -1 in front. You can distribute, that -1. And what we have now is, 4 minus 2i, which really doesn't need the parentheses around it because there's nothing to distribute in front of that. And then we have the next term would be minus -2. Minus -2 is plus 2. And then minus positive 7i, or minus 7i. And then just as the last example, I combine the real numbers, the 4 and the 2. 4 plus positive 2 is positive 6. And I combine the imaginary numbers for the next term, the imaginary part. -2i plus -7i. Well, -2 and -7 when combined make -9. So the next term is -9i. And there we go. I have my real number, 6, and then the pure imaginary number, -9i. And I mean, if you'd like to also, you can always rewrite this in that, remember that a plus bi form, where the real number a is 6, then plus, and then the imaginary part, the b, is -9 times I there, right? So a is 6, b is -9, but this is a lot cleaner looking. It's just 6 minus 9i. And again, do not put the 6 and the -9 together. Don't take 6 minus 9 and say it's -3. These do not go together. The -9 has I attached. The 6 does not. These are not like. They cannot go together. And that's it. That's as simple as that gets. All right, then my last example is going to refresh our memory as to, I did a previous video on evaluating square roots of negative real numbers. So hopefully you recall from that video the following rule, the following definition. If say capital N is some non-negative number, right? So say N is not negative, it's greater than or equal to 0. Then the square root of the opposite of N, right? So if N is not negative, then the opposite of N will not be positive, right? This will be a negative number in here or a non-positive number. You can rewrite the square root of a negative number as one of these pure imaginary numbers, right? Where you have a real number times that I times that square root of -1. The way to do that, the square root of -n, we're going to rewrite as the square root of n times I, right? Where remember I is the square root of -1, or you could say the number I, when squared, is -1. But this is key right here. And again, I brought this up in my past video on evaluating square roots of negative real numbers. So please, whenever you see the square root of a negative number, right, a non-real number, change it to this pure imaginary form. Write it as a pure imaginary number, a real number times I. So that's what I'm going to do here before I do any addition or subtraction. Okay, so in the first number, I have 4 minus, and then the square root of -4. Do this down here. The square root of a negative. This is not a real number, right? This, and according to what I just wrote here and in a past video, this is actually a pure imaginary number. I can rewrite this as a real number times I. The square root of -4 is equal to the square root of 4 times I, and there you go. There's a real number times I, but what is the square root of 4? That is 2. Right? So I'm going to rewrite the square root of -4 as this pure imaginary 2 times I. And you see it's complex. It's got that complex form, a plus bi. And then we're adding to that. The next complex number has, again, a real part of -7 plus, and then the square root of -9, again, is another non-real number, another one that I can write as a pure, this is a pure imaginary number. The square root of -9, I'm going to rewrite as the square root of +9, right, a real number, times that I times that square root of -1. And then, this is great and everything. This is a pure imaginary, but we can simplify the square root of 9, right? The square root of 9 is 3, or the principal square root of 9 is 3. And we have 3 times I. So instead of the square root of -9 there, I'm writing 3 times I. And now it becomes no different than my previous two examples. Right, I'm adding two numbers that are in the standard form, right, that a plus bi for a complex number. And this is addition here. There are no numbers other than 1 in front of these parentheses, so I don't really need the parentheses. There's nothing to distribute. So this is 4 minus 2i plus, -7. Right? Again, it's negative, so I usually put parentheses around those to make it look cleaner. And then plus 3i. All right, and then you combine, like terms. Combine your reals with your reals and your imaginaries with your imaginaries. So 4 I'm going to combine with negative 7, right? 4 plus negative 7 is negative 3. Right? So the real part of the sum is negative 3. And then the imaginary numbers, the pure imaginary terms, I've got negative 2i plus 3i. Negative 2 plus 3 is 1, so that's plus 1i. Positive 1i, or just plus I. Alright, and there you go. There is the sum of those two, complex numbers. And, the real part of the sum is negative 3. The imaginary part is positive 1. Right? The coefficient on I there is 1. And again, you don't put these together. One has I, one does not. Right? Just like you would with a variable and a polynomial, with variable terms. Great. Alright, so I guess the biggest thing to take away from this video is when adding or subtracting, complex numbers, you're going to treat I like a variable, right? And then you're doing your addition and subtraction the same way you would do addition and subtraction of polynomials, combining like terms, right? Combining reals with reals and pure imaginaries with pure imaginaries. Additionally, as in the last video I put up, whenever you see the square root of a negative, rewrite it as a pure imaginary, as a real number times I, and then go from there. And do this before you perform any operations. Alright, so you're going to do this before you do any addition or subtraction or multiplication or division even, as we'll see in a future video. Alright, and that's all I've got for those examples in that lesson today. And as I like to say at the end of these videos, do the best you can to learn the material on your own before you go looking for help. I have found over the years that people who tend to take the time and the effort to learn something on their own, they tend to remember things for longer and also remember them better and are more proud of themselves and all that. So of course, read the material, right? Read through the author's examples. Perhaps even try to work out some solutions to the author's examples before you see how the author did it, and then compare your work with the author's and see if you can learn from some mistakes there. Of course, do tons of exercises, practice problems, right? Sharpen your skills. Look for solutions to those if they're made available, so you can check yourself, keep track of your progress, see how you're doing. And don't give up on a problem or an exercise after the first or even second attempt. Don't give up so easily. Very often in mathematics there are several approaches that'll work for any particular problem. So if after several attempts at a problem, you're still not getting it, still not seeing how to do it, perhaps you should go back and try reading the material again, reading maybe even a third time, more slowly, more deliberately. Take good notes. Because if you've been doing some problems, there's a good chance you have a little bit better idea as to what the author is asking you for, what the author expects from you. So when you go back and read again, or read for that third time, you'll have a better idea as to what to look out for in the reading. Perhaps some things will pop out at you that didn't the first time through, and it'll make it that much easier to work on the exercises. But if after that, if after several read-throughs of the material and several attempts at problems, you're still not getting it, still not seeing it, it's not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos online. There's loads of those too. Videos like this one, or plenty of other ones out there that are better than mine. I assure you they're out there and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is also the hardest thing, is to stay positive about the subject. Believe in yourself, even through your struggles and failures and mistakes. If you keep at it and find a way to fix things, you keep practicing and keep reading, keep learning, and try to find a way to fix your mistakes. Those times when you struggle and fail and make mistakes, those are the times when you can learn the most, and it'll stick better when you learn through, when you push through and learn through a struggle and through a failure. So stay persistent, keep practicing, stay positive, right, and don't give up. And I just know you'll get it. And thank you very much for watching.